Okay, the purpose of this video is to show you how to add and subtract what I call complex rational expressions. Now, in order to do that, here's an example in front of you right here, but in order to do that, let's talk a little bit about what a complex rational expression is. I like to think of rational expressions, if you look at the root word in here, is ratio, right? And ratios are just fractions. So when you're basically complex rational expressions are just adding, subtracting, multiplying, and dividing fractions or ratios. Let me put a simple problem here off to the side to give you a demonstration. If I were to add like 1/2 plus 1/3, okay, how would you do that? Well, you'd look at the two denominators and you say, oh, I'd have to find a common denominator, wouldn't you? So I'd say the common denominator that 2 and 3 both go into is 6. So what I'm going to do is I'm going to multiply 1/2 by 3/3. Because when I do that, I'm going to get a denominator of 6, and you get a numerator of 3. So that becomes actually 3/6. In other words, I just changed 1/2 to 3/6. I'm going to do the same thing with the 1/3. I'm going to find a denominator of 6. So I'm going to multiply it by 2/2. Now notice when I multiply it by 3/3 and 2/2, I'm not changing the problem, right? I'm just multiplying by 1. 1 doesn't change the problem. But it does make it easier to solve. Now let me just go ahead and finish this one off. Multiply the numerator, you get 2. The denominator, you get 6. Aha! Now I can just add those together. 3/6 plus 2/6 gives me 5/6. So 1/2 plus 1/3 gives me 5/6, and that would be the answer. Now the reason I did that was because I wanted to show you the steps that were involved with adding fractions. We're going to do the same thing now with complex rational expressions. And the only difference between these and these is that rational expressions are fractions that have polynomials in them instead of numbers. Okay? So complex rational expressions are fractions with polynomials in them. Okay, so with that idea in mind, let's go ahead and see if we can solve or simplify this particular problem. Let's add these together. Now when I look at this denominator and this denominator, they're pretty close, aren't they? I'm going to try to make them the same. Now in order to figure out what's going to make them the same though, I have to have them in factored form. So you should always take your denominators, and your numerators for that matter, and factor them. That's going to be x plus 2, x minus 2, because that's a difference of squares. And over here I'm going to keep that the way it is. You know what? Now I can actually compare these two denominators, just like I can compare it up here. The difference between this denominator and this denominator is that this denominator over here on the right has an x plus 2 and this one doesn't. So how am I going to give this side an x plus 2 in the denominator? Well, just like I did with my fractions, I'm going to multiply by 1, except my 1 is going to be x plus 2 over x plus 2. Now I have my two denominators are exactly the same, just like these two numbers are exactly the same. So let's rewrite what I have here over the common denominator, just like we did over here. The common denominator is x plus 2, x minus 2. And then let me rewrite everything that's up here. I've got an x plus 2 times an x squared minus 1 plus an x plus 1. Now I'm trying to simplify this, right? And normally I would be able to start crossing out or canceling out numbers that would equal 1. But in this case I can't do that yet because I've got a plus sign here. Remember, there's a plus sign in between your your parentheses, you can't cross anything out. Everything has to be in a multiplied form. Okay, so I got a little bit of work to do here. How can I do that? Well, I think probably what I'll do is multiply these guys out, FOIL these, add them to the x plus 1, and see if what's left over is able to be factored. Okay, I know that sounds like a little bit of work, but that's what you're going to have to do, all right? So let's try it. X times x squared is x cubed minus x, or excuse me, plus 2x squared minus x minus 2, and then plus x plus 1. And then down here, I still have the same denominator. Now let's keep looking up here. Is there anything more I can do to simplify that? Well, I can add up my like terms, can't I? Let's try that. X cubed stays x cubed. 2x squared stays 2x squared. These x's cancel. Negative 2 and 1 become minus 1. And then this denominator stayed the same. Okay, now let me go ahead and look at this. Is there anything common there? Is there anything I can do to factor this trinomial? And I can't. And since you can't factor it, that'd be your final answer, okay? So when I go back up here, my original problem, x squared minus 1 over x minus 2 plus x plus 1 over x squared minus 4, the final answer becomes x cubed plus 2x squared minus 1 over x plus 2 times x minus 2. Now I've been asking my students to also tell me what the restrictions are. And if you look at the original problem and ask yourself what's going to cause that denominator to equal 0, right? You would say x cannot be 2, because if x were 2, then this denominator becomes 0 and the problem wouldn't work. So I'm going to say x cannot be 2. When I look at this denominator, factored out, right, if x is 2 or negative 2, negative 2 or positive 2, it would also cause the denominators to equal 0. Since I already had the 2, I don't need to rewrite that. So x cannot be 2 or negative 2, and there's my answer. Okay, I hope that helped. I'll try putting a couple more of these on there for you, and you can go ahead and follow the steps that we talked about.